Hello everyone, I'm Herdeline Ilumba from BPED 2B and this is the continuation of chapter 22. For today's topic, I will discuss about the physiology of obesity. First, let's tackle about the cause of obesity. There are, there are causes of obesity such as energy intake, energy expenditure, possible mechanism of obesity, long-term control of energy intake, and short-term control of energy intake. In which is the main driver of weight gain, the quality of the diet may exert its effect on energy balance through complex hormonal and neurological pathways. Next is overweight versus obesity. Some confusion exists regarding the precise meaning of the terms overweight, overfat, and obesity as they pertain to body composition and individuals' risk for health problems. In proper context, the term overweight simply refers to a body weight that exceeds some predetermined average for height. A person who is overweight has usually experienced an increase in body fat, but not always, as in the case of muscular athletes. Overfat is a term used to describe the condition of having more than a healthy amount of body fat. The term obesity refers to the overfat condition that accompanies a host of comorbidities, including glucose intolerance, insulin resistance, dyslipidemia, type 2 diabetes, hypertension, elevated plasma, leptin concentrations, increased visceral fat tissue, and increased risk for coronary heart disease and cancer. In most medical literature, the term overweight is used to describe an overfat condition. Even in the absence of accompanying body fat measures, in this context, obesity in most medical literature, the term overweight is used to describe an overfat condition, even in the absence of accompanying body fat measures. In this context, obesity then refers to individuals at the extreme end of the overweight continuum. This figure 22.1 trends in obesity among children and adolescents in United States and 1963 to 2008. Obesity is D6 and age-specific 95 percentile from the 2000 U.S. Centers of Disease Control and Prevention. Growth chart, data from CDC and NCHS, National Health Examination Surveys, ages 6 to 11 years, and ages 12 to 17 years, and the National Health and Nutrition Examination Surveys. Body composition, because BMI fails to consider the body's proportional distribution of body fat and the lean tissue. Healthy adults can be misdiagnosed by BMI as overweight or obese. When body composition mass is verified by a criterion method, such as dual energy X-ray, BMI may overestimate fatness in athletes and others who have a muscular build, false positive, and it may underestimate fatness in older persons and others who have lost muscles, false negative. The possibility of misclassifying someone as overweight using BMI standards applies particularly to large-size field athletes, bodybuilders, heavy wrestlers, and football players who tend to have large amount of muscle mass, which weight more than fat per unit volume. Muscle is more dense than fat, but does not contribute to a higher percentage of body fat. Although there are inherent problems with assessing fatness of an individual using the BMI method. It remains the method of choice for large-scale epidemiological studies because of the ease of obtaining the two measurements required for BMI calculation and its acceptable correlation with more technical measures, hydrostatic weighting, and skin fold measurements. However, the number obtained using BMI is not a measure of body composition, percent body fat, but merely a calculated ratio using height and weight. So next, there are specific health risks for excessive body fat include impaired cardiac function, hypertension, stroke, deep vein thrombosis, increased insulin resistance, renal disease, and sleep apnea and pulmonary disease, problems receiving anesthesia during surgery, and osteoarthritis, degenerative joint disease. And there are also endometrial, breast, prostate, and colon cancers, and abnormal plasma, lipid, and cholesterol levels. There are also gallbladder disease and psychological distress. So next, this picture shows about lean, overweight, and obese and severe obese. Year 22 to 3. The stage of fat cells, adiposities, and adipogenesis and lean and obese individuals. So fat mass in humans is the product of two factors. So there's our adiposity, adipocyte, size of volume, and total number of cells. And overweight individuals usually will have larger adiposities than lean individuals without significant changes in the total number. So a greater number of and larger adiposities will accompany obese individuals compared with their leaner counterparts. So these two factors are used to characterize the two main types of obesity. So there's our hyperplastic obese example 1 and hypertrophic obese example 2. So as shown at the bottom of the figure, when the individual moves further into the range of severe obesity, contributor factor to the increase in fat mass compared with cell volume. Cell volume at this point demonstrates a plateau response with no further increase in the severely obese range. So next is the impact of obesity across race and sex. Because being overweight or obese increases risk for cardiovascular disease, diabetes, and some types of cancer, it follows that overweight individuals would also be at greater risk for hospitalization than normal weight and individuals. In a study examining the association between weight status and all-cause and cause-specific hospitalizations between white and black men and women, researchers reported the average number of all-cause hospitalization per 1,000 adults to be 1,316 for normal weight individuals versus 1,543 for overweight adults and 2,025 for obese adults. Normal weight women had fewer hospitalizations overall than normal weight men, but the increase associated with obesity on all-cause hospitalizations was greater in women than in men. The differences between the number of hospitalization for either normal weight white and black adults and overweight or obese White and black adults were not significant. Other research, however, has shown that obese individuals in general have longer hospital stays and that obese black adults have longer hospital stays than obese white adults. Okay, so this work clearly demonstrates the cumulative burden of overweight and obesity on hospitalizations. The myriad of comorbidities, and given the high prevalence of obesity in these population groups, obesity prevention programs that target ethnic minorities and particular have a high potential to reduce healthcare costs associated with obesity-related hospital admissions. So that's all, and I hope nga may na-learn ka mo about sa physiology of obesity.